So this activity is one that I use to introduce geometry when I start this topic. I adapted it from an activity that I saw Nikki Vanderhout present at the Manswell conference. It has nothing to do with geometry, it's more a logic problem, a set of logic activities. And so we have these set of theorems and rules that we're allowed to use. So we're going to be given a string such as MU, and our aim is to produce this string here, MIU, IU, using any of these theorems above. So our first theorem is that if the string ends with the letter U, we can add the letter I to the end. Our second theorem is that we can convert any string that's MX into MXX, where X is any string of letters, so any bunch of I's and U's. 3 I's in a row can be changed into the letter U, and that's our third theorem. And the fourth theorem is that if I have 2 of the letter U's next to one another, we can cancel them out of a string. Now, the theorems aren't reversible. All right, so the first one that we might look at is problem D. All right, yeah. All right, so problem D asks us, given MI, produce MIUUI, giving reasons for each step. So we start with the string MI, and the one way that I've chosen to do this is I've gone MII, and then next to that I need to be writing which theorem I've used, so I've used theorem 2 here. And then I'm going to use theorem 2 again. So the string II is repeated, and I've used theorem 2 again. So I need to make it clear which theorem I'm using each time. All right, I'm going to use theorem 2 again. So it's the string II repeated, and I've used theorem 2. Next, what I'm going to do is I'm going to swap 3 of the letter U, I's for a letter U. And I've used theorem 3. And lastly, MIUUI. Hang on, which one was I doing? Yep, okay. And I've again used theorem 3. All right, I want you to have a go at, which one? Have a go at A and E, and I'll give you 1 minute. Yep.
Do any teachers make the students write entire sentences?
Oh, the theorem, the actual theorem?
Yes.
Possibly.
No abbreviations.
Oh, that is me.
So we're allowed to write alternate segment theorem? Or do we have to write the whole lot?
Insert up.
I got rid of this one.
Okay, time's up. Here's my solution to A. Here's my solution to A. Does everyone have the same solution? Does anyone have a different solution? Yep, can you read it out? Starting with MI.
So from MI, I went to MII, theorem 2.
Yep.
I went a really wrong way.
Okay, go. Yep, so theorem 2.
3 I's for theorem 2 again.
Oh, so it'll be 4, won't it?
Yep, and then 4,
Oh, yep.
and then 5, and then it was MIUI, and then MIUIU.
Okay, so theorem, which one's that? So just,
It's theorem 2 up until MIUI.
okay, so then we had 8 of the I's.
5 of the I's.
Oh, when we add the string, we're adding the whole lot.
Oh.
But that's okay, we can still get there. 1, 2, 3, 4, 5, 6, 7, 8. That's okay, it's good, and I'm glad it doesn't, yeah, it's, all right. Which theorem have I used here? Swapping. I've used theorem 3, thanks, and then MIU, IU. We get there. Okay, so how much longer have I got? Sorry. Super. Okay. So the whole purpose of this activity, as I said, is that it's actually got nothing to do with the geometry theorems, but it's a nice logic puzzle to introduce it. It's the whole idea that we're justifying every step that we do by putting a reason there. Why am I allowed to do this? Because I've got a theorem that justifies that. Also, we didn't do this the same way, and again, that comes up whenever we're doing geometry, because it's not about one right way of doing a geometry proof or setting it out. It's about eventually getting there. Yeah, we want to do it the most efficient way if we can, but it doesn't matter so long as we get there and so long as we're showing the reasoning. As a spoiler alert, the last one doesn't have a solution. And the reason behind that kind of delves then into some number theory. If you have a little go at it, I'm telling you now there's no solution, but 2 to the power of anything is not divisible by 3. So it's not divisible by 3. And then 2 to the n minus 3 is also not divisible by 3. And so we're sort of introducing some number theory there and products of prime powers and all of that sort of thing. So that's my activity. Yeah.